Hey, well, thanks everybody. Thanks for inviting me. Kim's right. My life is retrofits these days. So we have something like 14 million dwellings in Canada. 8 million of them are single family houses, about 6 million multis, including townhouses and high rises, and about 50,000 commercial and industrial buildings, or 500,000. So just roughly say 10,000 or 10 million buildings. And together they're responsible for about 28% of GHG's. Materials are about 18. I see varying tallies for this, but the thing that's not in question is that this is an existential amount of GHGs. As we've kind of worked on these and bumped into walls and are realizing how hard it is, I find myself occasionally saying, couldn't we just fix everything else and maybe like the grid and transportation and all that kind of stuff and not worry about buildings? But it's just not an option. We absolutely have to do it, or we're, on a sort of back of the envelope basis, we're guaranteed like 3.5 degrees on a global fair share. And we got to do it fast. So this is a graph for the emissions reduction in Edmonton to stay within a 1.5 degree fair share carbon budget. And if we don't follow the kind of curve on the bottom, we're going to blow through our budget in somewhere around 8 years. So it's crazy. So, and to give you an idea of just what this means, I'm going to focus on a project that's been my life for the last little while. This is the Sundance Housing Co-op. It's a 59 unit 1970s townhouse complex. We have a very enlightened, far-sighted client. They were about to renew their mortgage and their lease, and they said, wait a minute, maybe now's the time to look at what these buildings might need over the next long range of time. And so they commissioned ReNu Engineering to do a building condition assessment and an energy model to see what it would look like to make them net zero. And I used to live there, and I ended up involved in that. By sort of a fluke at the Passive House conference, the U.S. Passive Thisis conference in Seattle in 2017, I ran into Mark Carver, who was doing an Energiesprong type retrofit to an ATCO trailer in the CanMed Energy yard. And we talked about the Sundance project, and then he called me when the funding call for $2.5 million worth of R&D funding came available. So we pulled out all the stops, put in an application, and got the darn thing. And we were like a dog chasing a school bus. Then we formed a company to do this work. And I'm assuming everybody knows what Energiesprong is, but it's just in case. It's a system in the Netherlands where they're dealing with, they have hundreds of thousands of post-war townhouses that have virtually no insulation, well built, and they've developed a system where they do a LiDAR scan of the buildings, take that back to the office, and design panels that are built in a factory and come out and can do a group of townhouses in like 6 weeks or so. So sounds easy, right? Like we proposed that to the Sundance Co-op, and thought that because we had been doing stick by stick retrofits, and it sounded good to us. As we were doing the pilot building, I got a chance to tour some Energiesprong buildings in the Netherlands, and at lunch I held out these photos of the Sundance Housing Co-op existing conditions, and I said, Simon, what would you do like with those tight little jogs and these porches and doors that are jammed into corners where there's no room for a panel, cantilevers and stuff like that? And he said very cheerfully, oh, for us, that would be a no-go. So, in our sort of, I just thought, we're good builders. We're experienced. We're problem solvers. We can do this. Besides, we have to do them all, and we sort of thought that solving these problems, these are not unusual conditions by any means, would be good in terms of the big picture. So we got a LiDAR scan. The surveyor did 55 scans to pick up all facets of all of the buildings, and then smooshed them together into a giant 186 gigabyte file, where the redundant points are kind of eliminated, and then he clipped out the individual buildings for us, and then he sends us the individual building files that are 5 to 10 gigabytes. So they sort of look like the top left-hand corner there. We then, because we're on a budget, used a SketchUp plugin made in Netherlands that called Undet, that works extremely well. It has a multiple sort of geometry extraction functions. It can look at a sheet of points and pick the best fit plane, and so we do that. We can sort of bound that pick and get the walls. And then, like reality, these things are not level, plumb, or square. So with some judicious fudging, we can get the panels, or we can break the building up into panels that are orthogonal. But it's a nerve-wracking business. Like you're dealing with points. Locating the windows is a matter of sort of scooching it a few millimeters one way or the other and seeing if it's the best fit on the cloud. And it's I mean, you're going to hear about it if you've got that window off and the panels show up on site. So then we take that geometry and turn it into wall framing with window openings and lift points and WRB details and rain screen battens and that sort of thing for our panel partners in Killam, Alberta, who are basically framing these things on a 20-foot framing table, and sending them up to us. It's pretty low tech. And in addition to, somewhere around, 40 to 70 panel drawings per building, we have a booklet of standard details for the lift points, for the cellulose fill points, for window installation, and all of that kind of stuff. Installing the windows is one of the big advantages in the panels. This is very tedious work, as any passive house builder knows. Setting a window into a wall and detailing the WRB properly is is finicky, not something you want to do from scaffolding. So basically what we're doing is building a lightly framed 2x4 wall that we put on a panel support box, and then we fill the cellulose laparoscopically. And I'll just so they're about as cheap a panel as you can possibly build. And while the panels are being built, we're getting the foundation ready. So this is a full, almost net zero retrofit. Like we're doing everything. The co-op was very supportive. They wanted to get this done and never touch it again. I mean, that's really the way you want to do these kind of projects. But we're using a hydrovac to suck about a 6-inch slot around the foundation, and we drop EPS foam. We repair any cracks kind of with a roller and peel and stick as we find them, and then drop this foam in. We're using when we can get it, which is regularly now, but we've had trouble getting it, the graphite infused EPS for this. There were a couple of foundations where because of COVID supply stuff, it was not available. So that goes to just below grade, and then our panel support box gets bolted to the foundation and hung with framing straps, like the ledger gets and inside that panel support box, we're running the new services, and then we insulate it. The air barrier actually secures to the concrete and comes out to the panel face. And so while we're waiting for the panels, we're getting we're enlarging the basement windows to make egress. As I said, they want to do it once and never touch it again. We've got an egress sized window for every basement window, and we'll start loosening the windows so that on panel day we can move fast, because as soon as that window's out, there are people living here through the whole thing. So we've really got to minimize the amount of time that it's open. And then the big day, panel day, the first few buildings, we're on building number 10 of 15 now. The first few days was pretty nerve-wracking. I didn't want to go anywhere near the place because I was afraid that if there was a panel that didn't fit, somebody might knock my head off or something. But I'm happy to say that LiDAR and a little care and attention in making the panel drawings, every single panel has fit well. It's really like you might be out a few millimeters, which we have tolerance for. We have like 20 millimeters between the panels to slide them back and forth for the best fit on the windows. But you'll never put the window on the wrong side of the on the wrong side of the wall or something, as you might with a hand measurement. So at the end of the day, we've got a building that's got specs that are very similar to where we would design it to be a net zero building today. Might even make the Thisis standard for this climate zone. So we're about in the R30 average range for the foundation, little over R40 for the walls. When we count the original insulation, state-of-the-art fiberglass windows, and then we're putting a scissor truss roof over the top, adding another R50 to make it as I say, pretty close to where we would design a new building today. The cellulose, the site installed cellulose has been a bit hair raising. Like, it's pretty critical. You can't see what's going on, but we've kind of evolved a technique for doing it. We did some we did a fair bit of checking and some sort of drilling holes and making extra holes in the air barriers to pack it at the beginning, but we've developed a technique where we can direct the cellulose hose through quite a wide area using a piece of 1/2-inch PVC conduit tied to it. So it's a little bit clunky, but we're getting good bag count, just slightly over what you would need for around 4 pounds a cubic foot. So we think we've got it. And then once the panels are up, we seal the flaps on of the WRB. It's a Siga Mash Vest together in any of the holes that have been used to fill cellulose under the windows, and wrap it all together. We're getting pretty good air tightness. We haven't tested all the buildings, but we hit 0.7 on one of them. That's the CGSB test, not the passive house test. We started at about 3.5 to 4 on average with the buildings. We're now we're actually testing all the rest of them. NRC is actually paying to do that because we're doing a radon test as well. So for the roof, we're doing a scissor truss over. We were essentially wrapping the existing roof, cutting off the overhang, wrapping the existing roof in poly, and then making sure we've got enough cellulose over top to keep it well above the dew point. And in most cases, we're able to prefab the roofs and fly them up in big chunks. We're replacing the gas hot water tanks and furnaces with air source heat pump water heaters and Daikin Sky Air cold climate heat pumps, and of course adding HRVs, which we've gotten pretty good at installing laparoscopically. We found that we were able to take out the old B vent and use that chase to get the second floor HRV ducting up it and drop into the bathroom ceiling without any, like right where the old bathroom exhaust fan was, with essentially no touch up. The only we do have to open up a wall in the kitchen and on the main floor walls, but it's not too bad. We've had to learn to. This is a tight site with 59 outdoor units. We have to control the ice that comes off them. In Edmonton, the only icebergs that are growing in Alberta now are the ones under air source heat pumps in the winter, and they will not only wreck the unit, but we can't have it on sidewalks and that sort of thing. So we've developed these treated timber boxes that have enough capacity to hold it all winter. And we had to upgrade the electrical service. We started at with 60 amp service, which was not enough to run to electrify. So we had to completely resurface the site with which was an adventure in itself. And if some day in the bar when we're telling scary stories, I'll talk to you about demand charges. So, and then we're installing a 350 kilowatt solar array that will produce. Our roofs are not optimal. Most of these are facing kind of southwest, west-southwest, and they will produce about 75% of the total energy needs, and the rest is going to come from buying renewable sources from mostly it'll come from wind in southern Alberta. So the cost is around, and this I need to update this slide. This is post the first COVID shock, but we're closer to between 130, 135,000 per unit now, and I think we're getting a little faster. We'll probably finish okay that way. So that's one project. We got an opportunity to test our panel system on 3 single-family houses. I mean, with 8 million single-family houses to do, somehow we got to figure out how to do them, fast. I'm not sure whether panelization is the answer there. It's definitely faster. It doesn't, by the time you do all the digital capture and the panel drawing, I'm not sure if it's cheaper, but I think it saves personnel, and it's still, I'm still optimistic that we can refine the process, do it some more, and make it faster, automate some things. One of the things we've done here is we're working with a really smart grad student in computing science who is interested in, he's actually from the gaming world, and he's interested in photogrammetry. And he thought he could build an app that would do the digital capture a lot faster, and we don't have to worry about it being orthogonal because he can force it. And he's done that. So he flies a drone around the house, takes about 30 shots, picks the 10 with the best angle, and then by locating geometry in each of the slides, and his software will create a wireframe that once it's sized based on some, a big triangle on each of 2 sides, you can go around to the far side and be within 3 to 5 millimeters, which is plenty. So we're excited about that. The panelization is working okay on the 3 single family houses. It's really dramatic. People love it. But we've had to make some modifications in this particular house. They had already replaced 5 or 6 windows with Schuko windows, and it was insane to take them out and put them in the panels and then do jam extensions. So we had to sort of modify the panels to finish them on site, and it's just kind of a warning as to the sort of range of issues that lurk behind this challenge. Like in addition to, like, we're in touch with a group from Calgary that are doing 3 houses as well. Plus we've done a bunch ourselves, and there are, like, we're up to about 7 different ways of doing super insulated wall upgrades. And which one makes sense for each house really depends on the starting point of the house and the particular situation. It's really and the resources of the renovator. So it's a really one size does not fit all. One thing that's notable is that all of these good retrofits that I've seen so far have been done by passive house trained people, netzero and passive house trained people. Like, that is a critical part, like understanding airtightness, thermal bridging, and super insulation, plus how to renovate. That we need like an army of those people. The same thing with the roof. We're doing 3 houses and 3 different roof systems, and this one we couldn't add any weight to the roof, so we had to develop a kind of a exo site built truss that tied to the floor platform of the 2nd floor. It was a little bit of an arm wrestle with the structural engineer, but we made it work, and the second one we did, we were able to, it's a bungalow. We were able to use what they call flash and bat. So and again, these projects are for early adopters. Somebody blew about R50 of cellulose into that attic on top of the old shavings because they're keeners without touching the airtightness. And so we sucked it all out and couldn't reuse it, and filled it and laid down about 2 inches of spray foam, and then put new cellulose back in. So it's and then the last one we're doing scissor truss roof over, as we're doing at Sundance. and we've also done this built up roof on a number of projects where the structure will handle it. This is probably the cheapest, easiest buildup, but it only works if the structure will handle it. So it's like we've done, you know, we're learning from these projects and also from consulting on a bunch of others. And I want to talk about this one because it's for a young couple who just moved from Edmonton to Kingston to be closer to their both sets of parents. And they bought this little wartime bungalow with retrofitting in mind, and they can't afford to do it all at once. And so we have been working with them and a contractor that they've got to develop the phased approach that they can afford. And we're going to do the foundation first. They bought the thing during an insane market. It turns out that it needs weeping tile and some foundation repair. And so the obvious thing is to insulate the basement while that's happening. And while that's happening, the basement windows will get replaced, installed in the right way, and there'll be, you know, the high performance windows, so that phase can get done and never get touched again. And they also have vermiculite in the attic and very little insulation, so there's a big energy upside there. And so they're going to do the same thing, take out the existing vermiculite and do a spray foam air seal and then add cellulose on top. But before they do that, they're going to take out the old block chimney and run the HRV ducting for an HRV that they won't need quite yet, run that ducting in the attic, drop it into the bathroom, the kitchen, and put in a sleeve for PV before they do the spray foam. So again, they never have to go back into that attic. It will be ready, and they're going to take particular care at the edges to make sure they get right up to the edge, so that when the walls get done, a continuous air barrier can, you know, they can get a continuous air barrier. And so, you know, again, this, you know, in sort of meeting the house where it lives, this house started off with cedar siding. Somebody added 1.5 inches of white styrofoam underneath some aluminum siding, so the walls are not the weakest link, so they can wait. But eventually they will get done with either GPS or wood fiber board and new siding. And then at some point the mechanicals can get done. They would probably be able to do the heat pump electrification, this being in Ontario after phase 2, and the HRV at the same time. So what we've learned from all this is we've developed kind of a retrofit roadmap that you know, starts with before you do anything, you know, you do a building evaluation. What is that building going to need for the next 30, 40 years? Do the energy model, dial those together to come up with the best net zero ready solution set, and then map out a way to get there, either in one shot, which is always cheaper, or in planned stages. And it's remarkably complicated. Like you know, when we break out the steps and the feedback loops and that kind of stuff, you really almost need an IPD team to do it. And I think on commercial projects, which also need this sort of basic roadmap where you just say, okay, we're gonna map out what this building has to look like by 2050, and make sure that everything we do is the 2050 ready version of that building, and that nothing that we do is going to make it harder to tie into the remaining steps. Like it's kind of a no-brainer, but it's absolutely not what's being happened with envelope upgrades across the country. So that developing, we're working on refining this roadmap. We've sort of got it mapped out, and we're writing that up with a grant for EcoTrust, and we'll have that done in the next couple of months. And the other project that we can see is, because these things are so complex, we think it would be a lot simpler. And this is something like the gallery that Passive Buildings Canada has worked on, but I think taken farther and even more desperately needed, I think. So the idea would be that, if you've got a house, or if you're a contractor working on a house in Saskatoon, same climate zone as Edmonton, it's a semi-bungalow, you'll be able to go to the gallery and find similar project wherever in Edmonton, see the before and after specs, see what it costs, see what got done, and then with links to assemblies and details. And so it'd be a sort of a marketing piece to this, but also a technical support piece. And we've got to start on this on the Retrofit Canada. We've got a few case studies up, and we've got a bunch more in the works, and are going after funding to with this latest round of NRCan funding. We're going to team up with SAIT, Southern Alberta Institute of Technology, to try to get enough funding to do this properly, because the more we work on it, the more we realize it's a huge task. And to get the critical mass to make it useful and used is going to really take a full-time person. But our goal in the next couple of months is to populate this thing as much as we possibly can, to sort of demonstrate its efficacy, its value, and hopefully convince NRCan of the need for it, so that they'll fund it seriously. And we're looking for partnerships, and we should talk, and we also need your projects. If you guys are retrofitting projects, we really want to get them up here as quickly as we can. We've got an intake form that we're actually we're going to share with the Canadian home builders with their big project, and try to sort of harmonize this across the country, so we're all talking apples and apples. And there are a gazillion details. Like, I have never drawn so many details in my life. I think I've got a pretty good library just myself on these 4 projects. But and as I look out and see the sort of volume of houses we've got to retrofit, I think we need to build out this sort of supporting library of details that are linked to the case studies, and curated, and ideally building a community of practice where the good ones rise to the top. And the other thing that I think we need is a selection guide to help people choose from among major assemblies. So we're working on sort of mapping this all together. And I want to show you, that list is sort of meant to be not, you can't read it, not abstract, but one of the things on it is a problem we had to solve 3 times. We had additions over inaccessible crawl spaces. And so we came up with a way where we took the foam and sort of tongue and grooved it together, and sealed it into a big mat, and slid it in place and sort of sealing it as it was disappearing under there, and then used thick weather stripping to push it against the foundation, and left it so that we could tie our support box to it for continuous insulation and air sealing. And it's just like, there are so many of these kinds of issues that are, the panelization is cool, but retrofitting 10 million buildings is going to be mostly a labor intensive undertaking with a lot of on-site head scratching, like any big messy renovation. So it's terrifying, really, and we need an army of people to do this. I have no idea where we're going to get them. It's hard work. It's not as fun as building new buildings, our biggest challenge, like we were supposed to be finished by now, has been getting people, finding heat pump installers. We're on our third heat pump installer, and we're now crewed up pretty well. Things are humming along, but it sort of brings me. Does anybody know about the Shackleton ad? Ernest Shackleton, before he headed off to the South Pole, put this ad in some London newspaper, and I think we need a similar version for retrofitters, except they need passive house training too. And I think maybe if he'd taken some women, they might not have get lost on the ice, but I don't know. Anyway. Our community, our passive house community, is quite small. We're sort of doing some wonderful little projects, but we've got to figure out how to scale this. My God. And passive house is the starting point for sure. Like, we're not going to register very many of these projects. It doesn't matter, but the fundamentals of passive house training, the building science, the air tightness, the thermal bridging control, and all that kind of stuff is just fundamental to this workforce that is also needed to build more new houses. So I would love to have a chat then. Thank you.
Thank you, Peter. That was great. Very informative.